Dear student, here I want to solve a second order differential equation with a boundary condition. Here, solve mean I want to get the solution of y. That is, I want to generate data. If you want to plot x in the x-axis and y in the y-axis, I want to generate data for this equation. Here, the boundary condition is given when x equal to 0. It is given as 0, and when x equal to 1, it is given as 0. So these two boundary conditions are mentioned in the problem itself. Now I'm going to solve this problem using a bvp4c function in the MATLAB. To use bvp4c in the MATLAB, first we need to uh, split this equation into the vector. I'll be demonstrating that how that can be done here. For that, I'm going to divide y into y1, and differential of y1, the dy1 by dx will be equal to y2. Therefore, this equation become dy2 divided by dx, that is equal to d square y1 divided by dx square. Just I'm obtaining from this, okay? That is equal to minus pi square y. Now, as we define y equal to y of 1, I can write this equation as a minus pi square y of 1. I just modify this equation into the vector. How this can be written as a vector is, let me write d of dx can be written as y of 1 y2. Now just look at here. What is dy by dx? It's nothing but y2. What is the dy2 by dx? It's nothing but minus pi square y by, yeah, that's all. Now I have rewritten this equation into vector form. That is, I'm rewriting here d of dx y1 y2 will be fed to the MATLAB function as y2 and minus pi square y. We'll be calling this as a vector. Now I'll be writing this as a function in the MATLAB. Now just look at in the MATLAB function. I have written MATLAB function here. A function dy by dx, that is defined here, equal to ODE FUN. It is the user defined name, comma x comma y. So I need to pass x as the independent variable and y as the dependent variable. And you can look at here, I created vector. That is the first one, so y2 semicolon minus 5 power 2 multiplied by y1. That's what we have obtained here. Just I given this input into the system dy dx. So this can be considered dy dx equal to y2 minus pi square y1. I written in the language that can be communicated to the MATLAB. And the function should be written n with end. Now, if you run this, the file will be saved with the name of ODEFUN dot m. So save this file separately. And that's what the file name will be, the whatever thing I mentioned here. Now let us define boundary condition and the initial condition one by one. And next, I want to define the boundary condition. For that, let me clear these thing from my screen. As per the problem given here, the boundary conditions are y at 0, that is at x equal to 0 equal to 0, and y at 1 equal to 0. So at both the end, the boundary conditions are mentioned as 0. So it is easy to write the function again. I'm going to take the same, yeah, this boundary condition as given in the MATLAB code. Just look at here. I have written as it is comparable with the previous function creating, starting with function here dy dx. Here it is given, here is the output here. Similarly, here I want to use a residual, so I start with res and boundary condition function. Since I'm creating a function for the boundary condition bcfun, this is the user defined one. You can give whatever name you want, and what is the input should be given at the inlet. What is the ya value? At the outlet, what is the y value? And same res equal to ya of 1 and yb of 1, and n with function. Then the moment you're going to run, we know that the function, the script will be saved with the name of bcfun. Let me run the code. Yeah, it is saved with the bcfun. So you need to save both. You need to save both ODE equation as well as the boundary condition function separately. Now let us focus on the initial condition as well. Now I want to initialize my y value, that is the initial guess. Let me call it as initial guess from x equal to 0 to x equal to 1. The y value, let it be approximately equal uh, to the solution. It no need to be exact value since it is unknown to us. Since we have system of two equation, that is d of dx y of 1 and y of 2, that is nothing but dy by dx and minus pi square y. So these are the system of equation I'm having. Actually, this is my real solution. This is the, I no need to worry about the solution, but anyhow, let me give the boundary condition for this further. dy by dx is uh, 0 or 1 and 0. That's what I have done it here. In my code, I'm just initializing my guess. That is the function I'm going to call BVP. That is a boundary value problem, initial guess. I'm going to create the geometry uh, from 0 to 1 with a 10 division. Like that, I'm going to create a 10 division. That is the meaning, that is the lin space. If you just copy paste this line, just I'm copying and run it in the command window. Let me control V. So you can create, I'm creating from 0 to 1 of 10 values. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we're creating 10 values. Once I initialize my guess, then I'm going to call my boundary value problem function, that is a bvp4c. For that, I need to pass first the ODE function. That's what we defined already, the previous function. That is a ODE FUN, where we are given system of a differential equation. At ODE fun, yeah. Now, again, next thing I need to pass the boundary conditions. That's what we defined here. Then I need to initialize my guess. This is no need to be a solution near to the my original solution. It is approximately we can give the value. The moment I'm going to run this code, the code will be running. So I need to ask I need to rename it as my OD equation, OD BV equation. Let me save it as, and there's a plot created. I'll be explaining one by one here. Once you have executed these two lines, next what we are doing is here only the solution will be executed for the value which we have initialized from 0 to 10. That's what if you want to check here, just click on sol. Okay. And if you click on the sol, you can check here. The solution will be generated only for these values 0, 0 0.11, 0 0.222. Okay. And if you look at y, there are two solutions available 2 into 10. That is a two rows and a 10 columns. The first row and the second row. That's what if you look at the it gives the solution for the two system of equation, the first one and second one. Okay. That's what I want to find the solution of dy by dx. That is, I want to find the y. So I need to call this equation. Okay. Now let me uh, define. Let me close this one and just look at here. I am creating a new set of line where x equal to in space of 0 to 1, 0, comma 1 and 100. You know that I will going to create from 0 to 1, 100 points will be created as I executed the previous codes. Then once I've created x from 0 to 1, I'm going to interpolate the values from 0 to 1 for the newly created values of x. Okay. So this code will, this DEVAL will interpolate from this value, this solution, these two solutions, these two solutions. This is what I have done it here. Closing, closing it here. Just you can check it here. Uh, Once I have calculated y, just you can check, and you can check also here by here click on the y. Just create a two set of rows, one for one differential equation, another for another differential equation. And if you just look at closely here, the first equation, first row satisfy my boundary condition. When x equal to 0, y also equal to 0, and when x equal to 1, my y also 0. So I need to extract this row alone to plot a graph. So this is, I'm not interested. Okay, it is a solution for the another differential equation, y of 2. Okay, now what I'm interested is y of 1. For that, I'm going to write the another piece of code, plot x. So I'm going to plot x. What is my x? From 0 to 1, this is my plot. And since my y contains two set of rows, I'm going to extract only the first row. That's what I given y 1. It tells me that extract the first row and colon. That means that is that entire element. I'm going to extract entire element. If you're going to put uh, 1 to, I'll show it later. Yeah, I'll be just let me. If I'm going to put, look at here. I'm going to put here. You come on below. I'll show you here. I'm going to put uh, 5 to 7. Okay, it it shows me values of 0.15, 0.181, and 0.22. These values are thrown in front of me. Okay, and if I'm going to put y of first row, comma, colon, it will throw me entire, no need to define the values. Okay, this it throws me entire values from these are the values which throws me as the output. That's what I'm doing here. So I'm going to extract the first row only because I want to get the solution that is a y. So plot x comma y are one of one, and I want to r dash the line width up to. I'm just describing what should be the property of my plots. Then labeling, I want to label it as x axis as the x and the y axis is the solution of y of x. And I want to mention title as a solution of d square y by dx square that is equal to minus pi square y using PV, bvp4c. Okay, within the single quotation I have to give. Then I want to switch on the grid. Okay, and if I run the code, you can expect with all the labels which are defined here. Yeah, they executed now, and you can expect the solution in another window. So solution of y of x and labeled as x, and we can look at the plot at 0 x equal to 0, my y also 0, at x equal to 1, my y also 1. So this is the generated solution which satisfies my boundary condition. Thank you for watching the video.